Library, and today you are tuned into Homeschool at the Library, and we have been studying space. I am glad that you're here today, and we're going to end this space segment with Mars because of Perseverance landing on Mars last week. Here is a video of that happening.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Applicate indicates chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
Whew, what a great landing! And we are here right now on Mars. I am excited to be on Mars today, and I wish I had brought my coat because it's kind of cold here on Mars. It is around 80 degrees negative Fahrenheit, negative 80 degrees, typically on Mars. And a couple other facts I found out about Mars while being on here is Mars is actually the 4th planet from the sun. It is right next to Earth, but not really right next to it. We're just the next one over. Mars seems large when you look at pictures, but it's half the size of Earth. And another thing is it looks red, and that is why in ancient times the Romans called it Mars for the Roman war god that they that's who they named it after, and because of its red dust on its surface. In 1609, Galileo Galilei, through his telescope, was able to observe closer pictures of Mars. And in the late 1600s, there was a Dutch astronomer that did actual mapping and drawings, geographic drawings, because he was able to see closer some of the aspects of Mars. Mars actually has less gravity than Earth. If you weigh 75 pounds on Earth, on Mars, you would weigh approximately 28 pounds. So if you were wanting to lift weights on Mars, you could really lift some heavy weights very easy. A day at Mars, it rotates on its axis, actually is almost the same as Earth's. And rotating means it turns in a circle. And that's a little bit longer than Earth, but only by some minutes, not even an hour. It's like 24 hours and 39 minutes approximately it takes for one day to rotate around the sun, to orbit around the sun. What takes the Earth approximately 365 days, it takes Mars approximately 687 Earth days to go around the sun. And the surface of Mars is rocky. It's terrestrial, so it has rock ground. And the air is mostly made up of carbon dioxide, which is what we breathe out. So you wouldn't be able to breathe on Mars because they don't have oxygen like we do. So it doesn't have oxygen. Mars has 2 moons, and they think maybe they were asteroids that got caught on its gravitational pull, and there it's going around. So Mars has 2 moons. You can look that information up. And it has a lot of mountains and craters and a very large volcano, and actually has polar ice caps, kind of like we do, but the northern polar ice cap is really not liquid water because it doesn't have that there. It's actually frozen carbon dioxide, and that's what we make dry ice out of. So it's kind of like dry ice. And I'm trying to think of something else. There's been several rovers that have actually been to Mars and taking pictures, collecting rocks. And we had Spirit and Opportunity. There was Phoenix and Curiosity. We have a book on that in the children's department. And Perseverance just landed on February 18th. We just saw the video. Those are some information about Mars. Here are some books that we have at the library that I can show you. You are welcome to come and check out books about Mars. Look online, go to nasa.gov and look up information. Right now, we're going to get ready to do our craft right here on Mars. We have a craft bag for you this week. And we are going to make the helicopter that was on Perseverance that is going to hover. So we're just going to make a little model of that right now. But first, I want you to watch the video about the helicopter.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin compared to Earth's at Mars is less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
So, we actually have 2 crafts today, and the first one in our bag is, well, I put, just in case you didn't get them, a coloring page of Mars, coloring page of Perseverance, and then a coloring page of the helicopter that was on Perseverance that I printed off of NASA's website. So you can either print those out yourself, or you can come into the library and get those. We also have our craft paper, Build Your Own Mars Helicopter, that I printed. You can print it from the website, or you can come in and get a craft bag while you're checking out books. Inside your bag will be those coloring pages, a paper with the propeller, the blades, and the solar panel, some toothpicks, not for picking your teeth, and some marshmallows, not for eating. If you are going to eat a marshmallow, we have 1 larger marshmallow and 4 smaller marshmallows and 5 toothpicks. So we are going to get ready to make this together. Okay, so here's your supplies. Put your marshmallows, your toothpicks aside, and all you're going to do is cut out your rotor blade and solar panel. That's it. And if you make a mistake, it's okay. You can either tape it back together if you overcut, or if you don't stay on the line, that's okay as well. It will still be fun to do. It's kind of neat how this helicopter is going to be used to take some really neat pictures and travel further each day than the rovers can. Because it's just going to be taking and sending information back to NASA. Some really nice, they have nice cameras now. And I was reading that, like some of the images, like the dust, the wind, because there's wind, there is wind and storms that it can blow, it blows the dust off the camera lenses and things, so that's helpful for getting good pictures. That's it. And throw this away or cut it up and use it as scrap, recycle it, however. Okay, the next thing you're gonna do is just take and with a small and poke a hole in your rotor blade. That's it. These are a little bit sharper, so I'm just going to poke a little hole in it. There we go. You don't want to make it too big. And if you're younger and you want help from your parent, you may do that so you don't poke yourself. Okay? And that's it. You use those two. And then the next page, you just turn over and you're going to take one of the rotor blades and just stick your paper clip halfway through. Then take the other one and put it on top of that. That's it. Okay, so that's ready. And then you're going to take your marshmallows, and I did it kind of backwards. I guess on your paper they have you do this first. Poke your sticks in there for the legs. And you can poke them any angle you want. And then its little feet, I think I'll do it this way. A little bit longer. There. On the very back page, it has showing at the legs. And this is the fuselage, it said. So we just set it there. And this is a solar panel, so it's powered by solar energy. It's a good idea. Whoops, I broke my toothpick. That's okay. I was pushing too hard on it. And then you go ahead and poke that through like this, your solar panel, and then you're gonna put your toothpick on top. There, and there's your blades. Just like this. I'm gonna push one down a little bit, and you can look at a diagram of it and everything. And this is your helicopter. Now, you can fly it around. Pretend to take pictures. And there it is. It's kind of fun. I hope that you have fun making that simple craft. Okay, that was fun. Now, I thought it'd be really neat if you at home just got some stuff together and tried to make your own rover, your own Perseverance rover or another Mars rover, and you just kind of built one yourself. You could make it a robotic one if you wanted, or just for some fun, just get a box. So sure, we have a box here, some paper towel tubes, and then I cut them up, or toilet paper tubes. I found this rolling thing. This looks fun. Another box. I got some aluminum foil, and I got these because I thought, oh, these would be cute for, it's like what large tape would be on, for the wheels. And just some string, some scissors, marker, glue gun, staple glue. Old CDs that are all scratched up that you can't use anymore might be fun to use as the camera lenses. Whatever, just get some of your stuff at home and then build it however you want. And then it would be really neat if you sent me either a picture of it and we can post it, or you can just send it, or you could bring it into the library and we can put it on display on one of the shelves areas if you like. So go ahead and put your stuff together. I'm going to go ahead and build a small one here, and then I'll get right back to you to show you my design. Okay, so here is a little sample rover that I just made out of fun boxes, crafts and stuff. It was just fun putting it together. And this is my rover that's going to Mars. I used our flashlight from our constellation jars we made a few weeks back, and just put some stuff down, cut out holes of it, And that was this. So here's my rover, and I can't wait to see what you make. Thank you for joining me in this episode. Next week, we're going to do just a fun episode on how comics are written and the writing of comics and different things like that. And then after that, we will go ahead and meet live and do virtually. And that will be starting to focus in on Earth, and we'll start with the study of geology. So thank you for tuning in today, and I can't wait to meet back next week.